object, we will visualize the object in orthographic view, but there will be several hidden lines. That hidden lines means internal details we can't able to see directly. Thus we will show by hidden lines. So with such several hidden lines, it is complicated to identify or to visualize an object. So the internal details are shown by these sectional views. So sectional views are an important aspect of design since it is used to improve the clarity and reveal interior features of the part. So it will improve the clarity of the object and it reveal the interior portions of the object. Let's see an example. In this example, this hole is countersink hole is made that we can see here. In the orthographic view, we drawn only dotted lines. So this we can identify by sectioning the part into half. By sectioning the part of this portion, we can identify what is the internal counter board, what is provided that we can see. Where counter board is there and up to here it is open section. So that we can see here in the section view. So by cutting the object into at some place, we will get the section view. Next, what is the cutting plane? Cutting plane is that cuts through a component to create a sectional view. So if we want to cut at the center, this plane has to be provided. So this is the cutting plane. Here we cut this cutting plane at the center. So the cutting plane indication is shown according to in the perpendicular plane. So here in the front view we provided the cutting plane. In top view we can able to see only a line. So that is indicated like this. Top view, long dash and short dash is the indication of cutting plane. We represent in the top view by a line. In front view, the cut portion we will show. So opposite to the line. In top view, if we provided a line, in a front view, we will show the cut portion. So this plane cuts the object into two parts. So this portion here in this figure we will show here. This portion we will see in the sectional front view. And this cutting plane indication we will show by a single line. That indication with long and short dashes and direction of cutting. So direction of cutting is upward. So that we will shown in upward direction. So this is the representation of cutting plane and the opposite view of the cutting plane is the section view. And there are different types of sectional planes and types of typical shape of the section. So if we take a right circular cone, if we cut the right circular cone by passing through the apex and one base, so we will get a triangle. So the same section, the cutting plane is cut through the generators and inclined to the axis, we will get ellipses. So cutting the generators and inclined to the axis, we will get the shape of ellipse. And inclined to the axis and it cuts one generator and base, and away from the axis we will get parabola. And if the cutting plane is parallel to the axis and within the half of the before the axis we will get hyperbola. So similarly cylinder also we can cut the two generators and inclined to the axis we will get an ellipse. So these are some of the basic shapes that which we can get by different positions of the cutting plane for the right circular cone and the cylinder. Next, we are going to identify the section. What is the section? The projection of the section on the reference plane to which the section plane is perpendicular. Projection on the other plane is called apparent section. So to the section plane or cutting plane, the perpendicular. In the previous example, we have seen the cutting plane is in top view. So perpendicular to the cutting plane, that is front view. That means the cutting plane is in a horizontal vertical plane. In the horizontal plane, we will see the section. So like that, section is we can project of the section is on the perpendicular to the cutting plane. True shape of the section. So if you want the true shape, so if you cut the portion, what will be the true shape at that section will be shown by a plane parallel to the section plane. So So if the plane is parallel to the section plane, in that plane we can see the true shape of the section. So there are different types of possible cases we can discuss to identify the true shape of the section. So in first point, section plane is parallel to HP. So section plane is parallel to HP means the true shape of the section is in top view. So parallel to HP. In the horizontal plane we are having a section plane. So the true shape of the section we can identify from top. Similarly, the section plane or cutting plane is parallel to VP means we can see in front view. If it is inclined, according to that, if the cutting plane is inclined, then we have to draw a plane parallel to the cutting plane. In that plane, we can see the true shape of the section. If the plane is perpendicular, cutting plane is perpendicular to HP or VP, we can see the true shape of the section in side view. So here we discuss the section plane is inclined. So section plane is inclined means perpendicular to VP and inclined to HP. So the section plane appears as a straight line in front view, perpendicular to VP. Section plane is perpendicular to VP means in other view we can identify the section. So the section plane appears as a straight line in front view. Similarly, section plane perpendicular to HP means the section plane appears as a straight line in top view. And in other view we will get an auxiliary projection, that means reduced size of the true shape. The true shape we will get parallel to the cutting plane, which is inclined to HP or VP. So let us see the terms. So here section plane is inclined to HP. So inclined to HP means we can identify the sectional top view. Here this section is not of the true length, true dimension. The true shape of the section we will identify when we run parallel to the section plane. So here the section plane is this. Parallel to the section plane we have drawn the true shape of the section. So the other view in the top in front view we have section plane. In the top view we will get sectional top view. So the apparent shape of the section we discussed already. The reduced true shape is the apparent shape of the section that we can see in the sectional top view. This section in the portion, that means cut portion, will indicated by drawing lines 45 degrees to the XY plane. So the cut portion is shown by 45 degrees lines. These lines are drawn 45 degrees to the XY plane, irrespective of the shape of the top view or front view, anything. The section lines are identified by drawing 45 degrees to the XY plane. So let us go for an example. A pentagonal prism, 30 mm base side, 50 mm axis is standing on HPM space, one side is perpendicular to HP. It's cut by a section length 45 degrees inclined to VP through midpoint. So first draw the views. Pentagonal prism standing on HP. Standing on HP means in top view we will get the true shape of the prism, base, shape of the base. And it is prism, here we will get a rectangle in opposite, and the section plane is 45 degrees inclined, and it is passing through the midpoint, 45 degrees inclined and passing through the midpoint of the axis. So now we draw the front view and the top view. Similarly, we can construct the side view. This and all we already discussed in college. So after getting the front view, top view and side view, now we are going to construct the sectional top view. So how we will draw the sectional top view? Just project from every point, A dash to A, B dash to B and E, similarly C, D. So this total section we will get. So this is the total section. Now we have to draw the true shape of the section. So true shape of the section means already we have discussed, if it is inclined, the plane parallel to the cutting plane, we will give the true shape of the section. So x1, y1 is the new plane parallel to the cutting plane, and just project from each and every point and mark the distances of the top view from XY plane from x1 y1 plane. So from xy to A, that is marked here, xy to E, that is marked here. Similarly, xy to B marked here, xy to D, it is marked here, xy to C marked here. So that and all we can join, and that is the true shape of the section. So here we can easily identify that it is reduced. This sectional top view, this true shape is reduced. So like that we have to identify the true shape of the section, and the sectional top views are front view according to the plane given. So here the section plane is inclined to HP, so you will get sectional top view. If the section plane is inclined to VP, we will get sectional front view, and this cutting plane we will show in top.